In the last video, we measured the pH of a buffer solution with acetic acid and acetate, and we also measured the pH when we added a strong acid. And we did this using ICE tables. So it turns out that there's an equation that we can use for buffer solutions under certain conditions that's a little more straightforward. So we're going to derive that. So we are going to start with the equilibrium expression, or the equilibrium expression for a weak acid that's hydrolyzed, our Ka. So this is what our equilibrium expression is for the hydrolysis of a weak acid. If we rearrange that to solve for the concentration of our hydronium ions, this is what we get. And then if we take the negative log of both sides, we have the negative log of our hydronium ion concentration. We have the negative log of our Ka minus the negative log of the ratio of our acid to its conjugate base. So you may notice the negative log of our hydronium ion concentration, right, is just our pH. It's pH. And then the negative log of Ka, we reduce that to pKa plus the log of the ratio of our conjugate weak base and to weak acid. So this equation is called the Hendersen Hasselbach equation. And this is how we derive it from our ionization constant expression for weak acid solution. So this equation relates the pH, the ionization constant, right, which is just the negative log of the ionization constant, and the concentrations of the weak conjugate acid-base pair in a buffered solution. So we can use this equation to determine the pH. We can also do the reverse, right? Let's say we know the pH and we want to figure out, right, if we want to make a buffer at a certain pH, we can figure out what concentrations of our conjugate acid-base pair we should have to make a solution at that pH. The important thing to remember is that we can only use this equation if the simplified assumption applies. And remember, the simplified assumption only applies if our Ka value is small, right? If our Ka value is small. If it is small, then we can use the Hendersen-Hasselbach equation for relating pH or concentrations of our weak conjugate acid-base pair.